Hey guys, so we've now reached the boss level in our binomial expansion adventures. We are now going to take a look at expanding things like a plus b to the power of n. So far we've looked at expanding 1 plus x to the power of n. We've looked at putting a coefficient on the x term, things of the form 1 plus ax to the power of n. Here a and b are going to have different coefficients than 1. So a is usually our constant term and b is usually our x term. So there is a formula, so let's take a look at that first of all. Okay, so we want to expand a plus b to the power of n. Now it's not really a brand new formula, it's just an evolution of the formulas that we've seen so far in this chapter. So, I'm going to write it out a bit differently, first of all, before I give you the form that will probably be in your formula booklet. So, the first term is going to be a to the power of n times b to the power 0. So that is the first term in the expansion. So something to look out for here straight away is that the power of a and the power of b have to add together to give you n. So there's a little pattern that goes on here. The next term, well, that's going to be n choose 1 times a to the power n minus 1 times b to the power of 1. So we can see there the power of a has gone down by 1, the power of b has gone up by 1. So this pattern continues. So our next term is going to be n choose 2 times a to the power n minus 2 times b to the power 2. So again, the power of a has gone down by 1, the power of b has gone up by 1. So what do you reckon our next term is going to be? Well, it's going to be n choose 3 a to the n minus 3 times b to the 3. So again, the power of a goes down by 1, the power of b goes up by 1. So this pattern continues all the way up until the final term, which is a to the power 0 b to the power n. So, see if we can get that all on one screen. So that's looking something like that. Now, of course, we can tidy this up a tiny little bit by getting rid of the to the power 0 terms. The reason I put those in is to try and make it clearer what's happening. So, of course, any number to the power of 0 is just 1. So we actually get a to the power n plus n choose 1, a to the n minus 1 times b, and then plus n choose 2, a to the n minus 2, b to the 2, and then that carries on all the way to our final term, which is just b to the power n. So this is the formula in the form that you want to get nice and familiar with, and we're now going to practice using it. Okay, first example then, we want to fully expand 2 plus 3x to the power of 4. So here, a is 2 and b is 3x. Now we got a small power So I'm going to use Pascal's triangle to find my coefficients. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So those are the guys that we want. So instead of thinking of this as a formula, to be honest, I don't really like to think of it as a formula. So I just like to think about what's happening. So the first coefficient, the first term, has coefficient 1. And then we're going to have 2 to the power of 4. So that is our first term. Now the second term has coefficient 4. Now the power of 2 is going to go down by 1, so 2 cubed. And now we're going to have 3x to the power of 1. So then the next term has coefficient 6. The power of 2 goes down by 1, so we're going to have 2 squared. The power of 3x goes up by 1, so we got 3x all squared. The next term has a coefficient of 4. The power of 2 goes down by 1, so it's just 2. The power of 3x goes up by 1 to a power of 3. And then our final term is 3x to the power of 4. Like that. So now we just need to go through and simplify. So our first term, 2 to the power of 4, is 16. Then our second term, well, 2 cubed is 8. 8 times 4 is 32. So we got 32 times 3x, which is going to give us 96x. And then for our third term, well, this time 2 squared is 4. 4 times 6 is 24. And then we've got 3x squared, which is going to give us 9x squared. So we've got 24 times 9x squared. Now that is going to give us 216x squared. And our next term, well, 3x cubed is 27x cubed. 4 times 2 is 8. So we've got 8 times 27x cubed. Now 8 times 27 on a good day is something like 216 as well. So we got 216x cubed, and then our final term, 3x all to the power of 4 is 81x to the power of 4. So that is our first big bad binomial expansion. Good times. Okay, next example. So the first 4 terms of 3 plus 4x to the power of 6 in ascending powers of x. So, slightly bigger power, so I'm not going to use Pascal. So, our first term then, well, a is 3 and b is 4x. So, our first term is going to be 3 to the power of 6. Our next term is going to be 6, choose 1, 3 to the power of 5 times 4x. Then we're going to have 6, choose 2, times 3 to the power of 4 times 4x all squared, and then our final term is going to be 6 choose 3 times 3 cubed 3 cubed times 4x all cubed. So what we're going to find here is that we get some really massive numbers. So I definitely need my calculator. Okay, so we get 729 plus 5,832x plus 19,440x squared, and then for our final term we get 34,560x cubed. So yeah, our numbers get quite big doing these type of expansions, but there we go. Okay, one more for this video then. For this one then, we're sticking a negative inside of our bracket, so we got 5 minus 2x cubed. So, small power, Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So those are the coefficients that we need. Here then, A is 5 and B is minus 2x. So be really careful when you have negatives. Okay, so our first term then is going to be 1 lots of 5 to the power 3. And our second term is going to be, well, our coefficient is 3. So we got 3 lots of 5 squared times minus 2x. Then we've got 3 lots of 5 to the power 1 times minus 2x squared. And then our final term is, well, plus minus 2x all cubed. So let's sort that out now then. Okay, so 5 cubed is 125. And then we've got 3 lots of 5 squared times minus 2x. 5 cubed, 5 squared. So 5 squared is 25, times 3 is 75, times minus 2 is going to give us minus 150x. And our next term, well, minus 2x squared is positive 4x squared. So we've got 4 times 5, which is 20, times 3, so we get plus 60x squared. And then our final term, minus 2x all cubed, is minus 8x cubed. So that's our expansion of 5 minus 2x cubed. Okay guys, that's it for this video. In the next, we'll look at more examples with negatives and also fractions, and another way that we can think of, well, doing these. Okay, take it easy guys.